Good morning all. I am Virendra Kumar. I welcome to all in this video. In previous video, I have explained about bearing and belt. In bearing, I have told digits specification like suppose one bearing is I have taken example 6304 2RS. Then I have told 6 is the type of bearing. Which type of bearing? No, one groove bearing, ball bearing or a cylindrical bearing. अगर two types, two double row ball bearing or single groove ball bearing. Next, second digit I have told this is the load on the bearing, medium load, high load, light load or heavy load. Okay. Next, last two digits I have told last two digits determine the soft dia or bearing internal dia. Okay. Next, last two numbers is 2RS. 2RS means suppose here 2RS given the both two sides rubber shade bearing. Suppose here double Z is given. Sometimes bearing written double Z. Double Z means metal shell bearing. Okay. Next, in belt side I have told A, B, C, D types of belts depend upon the load transmitting the energy. I have explained. Suppose I have also example I have taken B58. B means type of load, medium loads, and 58 means this is the suppose this is a belt and I have cut it and spread one in one rope like a, then length in inches it will come circumference or length of belt equal to 58 inches. In this video I will explain here fan. In refrigeration air conditioning we are using fan, two types of fan mostly we are using. In condenser side we are using axial fan. But we are, what is the fan? Fan actually this is a fan is a powered machine that create airflow. Without airflow heat transfer will not possible. So we for heat transfer we need to flow, so we need to flow air from suppose one side to another side, same blower also from room to evaporator coil we have to circulate. So fan is the powered machine that circulate or blow the air. Okay. Next I am coming fan. I told two types of fan is there. First is axial fan. We are using ceiling fan. What means we are using ceiling fan? This is the axial fan. Here ceiling fan. Why here? Well, suppose this is a roof. Okay, this is a roof and this is the fan. Here shaft is there. What shaft? Shaft position and air flow, direction of air flow, same direction means what? That is the axial fan. Axial fan, type of axial fan. Okay. Suppose in another one centrifugal fan. Suppose shaft is there. Here I am taking example. One shaft. This is the blower. So what I here this rotation, shaft rotation is this type, circular. But air is vertical or vertical position, perpendicular position. Then this is the airflow is perpendicular. Then this fan type of fan will be called centrifugal fan. Okay. Now some laws is there. So three laws is there according to suppose we are need to change air quantity, then we have to increase. We suppose we want to increase air quantity in supply for supply in room, then we will have to what? We will have to increase the RPM or speed of the motor. Next, suppose we are to increase the static pressure, means how much we are supplying air, continuously supplying the air. Suppose outside air we are supplying continuously. What happens here? Pressure will generate. That pressure is called static pressure. Okay. So suppose now I have told here power requirement. What will affect in power consumed? We are increasing the RPM. We for air quantity we want more air quantity, though we are increasing the speed of the motor. Then what will affect here? Static pressure will increase. Then power requirement will also increase. But how much increase? Then we will calculate By the formula first I will tell. Suppose air quantity is directly proportional to RPM. Means air quantity, suppose we want to increase, means we should increase the speed of the motor or RPM of the motor. Suppose we want to decrease, then what? Then we will have to reduce the RPM of the blower or fan motor. Okay. Next we want to increase, same, we want to increase static pressure. I told you static pressure. Then what we have to increase, but it will increase. Static pressure will increase in square form. Okay. And power consumed increase with cubic form. What? Cubic power. Okay. Now I will take an example. Suppose one motor runs with 100 rpm and consumed power 7 kilowatt and maintain pressure 1 mm with air delivering 10 meter cube per minute. If speed of motor increased by 100 to 200 rpm, then what will affect air quantity and static pressure and power consumed. Okay. And here given N1 means first RPM, how much? 100. Then we are increased 200 RPM. Then SP1 1 mm and HP1 means power consumed. First that one power consumed. Then 7 kilowatt, 7 watt. Now quantity of air that time they are delivering 10 meter cube per minute air delivering. Okay. Then now we can find by this relation and this formula easily we can find out Q2 equal to N2 by N1. By this one here Q2 we are finding out, then here it will go multiply here Q2 by Q1 equal to N2 by N1. Then Q1 we want to, so Q2 we want, then here Q2 equal to N2 by N1 multiplied by Q1. Suppose then N2 by N1 200 by 100 into 10 first delivery Q1 equal to 10 given 10, this is equal to 2 into 10 means what? Air quantity, suppose we are increasing speed of the motor twice or RPM we are doing twice, then what will air quantity will be twice. Okay. 2 into 10 before 10, now 2 into 20 2 times multiplied. Okay. Next static pressure, and I am telling square form, it increase by square form N2 by N1 into SP1 200 by 100 square, it is equal to 200 0 will be cancelled and 2 square it will come 4 into 1 because SP1 equal to 1 mm water gauge, so 4 into 1 means 4 times. Suppose we are speed of motor increasing 2 times, then static pressure will be increased 4 times. Okay. Because 4 into 1 equal to 4. Now power consumed, I am telling power consumed in cubic form, sorry, here it will come cubic form. Then power consumed N2 by N1 cube into SP1A before power consumed, before it consumes 7 watt. Now it will how much consume? 200 by 100 cancel, it will come 2 cube means 2 2 ja 4 2 ja 8 into 7 means before it is consumed, before consumed same, now 8 times power. Suppose we are motor speed we are increased, then power consumed will be 8 times. Understand how much more? In VFD what we are doing in variable phase, now we are installation we are using, so sometimes you have listened the inverter technology. What doing? Inverter technology as per requirement it will reduce or increase the RPM of the motor. Okay, so we are increasing RPM here, so we are, suppose we want to increase air quantity means we are increasing the RPM, then it will consume more power. Suppose design temperature reach means what happen? It will RPM will be reduced. Then RPM will be reduced means power consume also will be reduced. So much reduced. Here 8 times increase, then 8 times also decrease. Suppose half we have given means what happened? Suppose speed half we given means here power consume also 1 upon 8 by 7. 8 times. What? Divided 1 by 8. Power will be reduced. So much reduced. So that's why we are energy saving. We are technology, inverter technology is the energy saving equipments. We are preference giving all VFD or inverter technology. That's the region. All suppose here washing machine, some all motorized items we are using. We should also use all inverter as per load. We can be reduced or it can be increased. Okay, thank you. In this video, in next video, next topic I will take. Okay, thank you for the watching. Bye.